What's up, guys? So we're going to move on to a second method for solving quadratic equations. The first one that we talked about was using factoring. Okay, so to factor, get everything into standard form, factor the left-hand side, and then set your two factors equal to 0, which works great if the equation is factorable. However, today we're going to talk about, well, what do we do if it's not factorable? What are we supposed to do? How do we handle that? Which, to be honest, is kind of the more common scenario. Okay, so what I want you to do right now is solve these quadratic equations in your notes. We're going to use these as kind of a model for what we're going to do today. So go ahead and pause here and then solve these. Okay, so if you did this the long way, it might have taken you a couple minutes longer than normal because you have, a a number in front of the x squared, or you could have noticed that these actually follow the a squared plus 2ab plus b squared format. Okay, except for the first one, which actually follows the a squared minus 2ab plus b squared format. So we have a perfect square here in the first term, and then a perfect square in the third term. So they actually do follow that pattern. So they are going to factor down to an a plus b squared. And in the case of the first one, it's going to factor down to an a minus b squared. And I told you guys you probably want to memorize that little formula, this pattern. It's going to make your life easier today, okay? Because what we're going to do is, remember, these are called perfect square trinomials. Okay? And they're called that because they actually factor down to a single binomial squared. All right, so we can use this pattern, excuse me, to factor this. So we're going to factor the 4x squared minus 4x plus 1, and that's going to factor down to a 2x minus 1 squared. The second one is going to factor down to 2x plus 3 squared. Right? Because we're looking at this first term and the third term, and then we're also paying attention to the sign that's in between the first and second. Okay, that's just the pattern. If you did it the long way and did a times c and then find the product of that, or the factors of that added up to the middle b term, that's fine. It's just a much longer way to go about this. All right, so this third one is going to factor down to if we look at 16x squared, that's 4x times 4x. I have a plus here, so it's going to be a plus here. And then I have a 9 here, which is 3 times 3. So those are my two factors. Now, if I use that zero product property and set the factor to 0, like we have here, right? Then that means my solution, if I add 1 and divide by 2, is going to be 1/2. For the second one, it would just be 2x plus 3 equals 0. So my solution after I subtract 3 and divide by 2 is going to be negative 3 over 2. And for the third one, 4x plus 3 equals 0 is going to give me an x of negative 3 over 4. Right? Subtract 3, divide by 4. So that's the quick and easy way to do this when we have a perfect square trinomial set equal to 0. Okay, so we're going to use that today. So just a little note here, if you didn't notice the pattern, that was the pattern. So today is 7.2, solving quadratic equations by completing the square. So this is like the short and easy title, completing the square. And we're going to use this when it's not factorable. Okay, so you can probably add that when it's not factorable. Factoring it is definitely the easier way to go, but unfortunately they're not always factorable. So let's take a step back to something we did earlier in the year when we talk about taking the square roots to undo a perfect square, right? So if we look way, way, way back, if I said that we had an x squared equals 16, remember the goal of solving any equation is to figure out what number makes that a true statement. And if you said 4, you'd be correct, right? Because 4 squared is 16, so x could be equal to 4. However, because we have a square here, right? We have an x value that's squared. We also have the possibility that x could be equal to negative 4, right? Because if I squared negative 4, I also get 16. So negative 4 times negative 4. So let's take that a step further and say, well, what if it's not a perfect square? All right. Well, because we have an x squared, we're going to take the square root of the left. So that gives us x. And whatever I do to one side, I have to do to the right side, right? So I take the square root of 8. But because I have to account for the fact that this could be a positive or a negative, we're going to use this little symbol, which is just a plus or minus. Okay, it literally just means plus or minus. So plus or minus the square root of 8 would be the two solutions that make this a true statement. I have a positive radical 8 or square root of 8, and I have a negative square root of 8. And hopefully you remember, it hasn't been that long, but hopefully you remember we do need to simplify the square root of 8, right? So we break it down into its little factor tree, right? If I did 8, it's 2 and 4, and 2 and 2. I have a pair of 2's, so that means I get to move. Let me fix this here. I get to move a pair of 2's out. So it's plus or minus 2 times the square root of 2. And then this would represent my two solutions that make this equation true. So let's take it one more step forward, which now it looks like, sort of looks like, the equation that we just solved that were factorable, right? I have an x minus 1 squared, so now I have a quantity squared. And we're still going to handle it the same way. I'm still going to take the square root of that to undo the square. And the same thing is going to happen on the right, except now I have to account for the fact that it's plus or minus the square root of 25. Okay? Now remember, our goal is to get x by itself. So from here, I have to actually add 1 to both sides to get x by itself. So I'm going to add 1 over here. Now I'm going to simplify. So what I actually have is x being equal to 1 plus or minus. Remember, the square root of 25 is a perfect square, so that's actually 5. So I have two solutions just like before. I have one solution where it's plus 5, and my second solution would be when it's minus 5. So I have to account for both of those. So my two answers are going to be 6 and negative 4. So both of those numbers make that a true statement. If you want to check that, you can. You can actually do it really quickly mentally. 6, oh sorry, that's my reminder. 6 minus 1 would be 5. 5 squared is 25, so that's true. And then negative 4, right? If I plugged in negative 4 minus 1 is negative 5. Negative 5 squared is also 25. So these are both two true statements. All right, so go ahead and let's test how well you understand that concept. Let's just do the same exact thing. So pause the video for a second and try these three on your own in your notes. Okay, so if you take the square root of both sides, that's going to undo this square. All right, so I'm gonna be left with an x plus 3 equals, and don't forget the plus minus to account for the positive and negative version of that. Then we're going to subtract 3 from both sides. Okay, so I have a negative 3 plus the square root of 18 and a negative 3 minus the square root of 18. So the only thing, because 18 is not a perfect square, I do need to still figure out if I can simplify the square root of 18. So if I take 18 and I start dividing it by 2 because it's even, it's going to be 9, and 9 is 3 and 3. So I actually do have a pair of 3's. So I can simplify this a little more by saying that x is equal to negative 3 plus or minus 3, right, because I got a pair of 3's, times the square root of 2. Because I don't have two radicals that are the same, hopefully you remember the rule that they have to be the exact same radical in order to add or subtract them. So this is actually as far as I can take this. Okay, so these are my two answers. Remember, these are actually, in fact, two answers. I have negative 3 plus 3 radical 2 and negative 3 minus 3 radical 2. Okay, for the second one, again, I'm going to take the square root of both sides. So that's going to undo the square. So I have x minus 6 equals plus or minus the square root of 27. Then I'm going to add 6 because I have a negative 6. So add 6 to both sides. So now x is by itself. And then I want to see if I can simplify 27, which is going to be, that's a 7. 3 times 9 and 3 times 3. So this actually does simplify. We're going to be having an x that's equal to 6 plus or minus 3 radical 3. So again, these are my two solutions. I can't simplify anymore, so I can't really combine those. For the third one, square root of both sides. You can see the more you do this, the faster it gets, hopefully. So x plus 5, because we undo the square, equals plus or minus the square root of 20. Square root of 20, oh sorry, let's subtract 5. Square root of 20 is going to simplify. It's 2 times 10 and 2 times 5. So I actually have a pair of 2's with a 5 left over. So my solution set for 3 would be negative 5 plus or minus 2 radical 5. All right, and that's about as simplified as I can make that one, so that's going to be my solutions. All right, so let's talk about what's going to happen, or what do we do if it's not factorable? How do we make something that's not factorable match one of our patterns, right? Either a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So how do we make it match that pattern so that it factors, so that it factors down to a plus b squared, or in this case, a minus b squared. All right, so we're going to do what's called completing the square. So in other words, we're going to make it, we're going to force it to match that pattern. All right, so we're going to start by using this example. It carries over onto this next slide here. So here's the steps. I'm actually going to come back to this slide so you'll have a chance to write it down. But what we want to focus on here is that this method is always going to work if our a value is 1. So remember, we have a 1 here that we just don't see. And we're going to use this magic little expression of b divided by 2 squared. That's going to give us our perfect square trinomial. All right, so the first thing we have to do, step 1, is to move the constant. Remember, this is our constant, negative 17. We need to move it to the other side because it's not a perfect square and it's not helping us at all. So we're going to move it to the right. The second thing we're going to do is we're going to figure out, well, what are we going to add to both sides? And we're going to use this expression of b divided by 2 squared, and we're going to add that to both sides. We have to add it to both because whatever I do to one side, I got to do it to the other side. And that's going to give us our perfect square trinomial on the left so that we can solve this just like the ones we were just looking at. All right, so let's look at this in more detail. So the first thing we're going to do is add 17 to both sides. Okay, now watch how I write this. I'm going to actually leave a space or a little gap right after my middle term. So I'm going to add some mystery number. I'm going to add a blank. And I've moved 17 over, so I have 17. And then whatever I add to the left, I have to add to the right. Okay? So I have kind of the sort of structure of the perfect square trinomial on the left. All I'm missing is this mystery perfect square that I need to add. So we're going to use the b over 2 squared expression. So remember, this 18 is my b, right? This is b. This is a, and this would be where c is. So we're going to plug in a b. So 18 divided by 2, and we're going to square that. So 18 over 2 is 9. 9 squared is 81. So this actually gives me my perfect square that I'm going to add to both sides. Okay? So now hopefully you see this new trinomial here actually matches our pattern, right? It matches the a squared plus 2ab plus b squared pattern. So we know that it's going to factor to a plus b squared. So I'm going to factor it down. So this is going to factor down to x plus 9 squared, right? Because 9 times 9 is 81. 1 times 1 is 1. And then I have to, of course, add 17 and 81, so that's going to give me 98. All right, so now it looks like, just like the ones we were just doing, so we're going to continue from here just like we did before. We're going to take the square root of this side, the left, which is going to get rid of this square. So x plus 9 equals. And then we have to do the same thing to the right side, but we also have to remember it is plus or minus because we have two solutions. We have to account for the positive and the negative possibility. And then we're going to subtract 9 from both sides. And then the only thing left to do is to try to simplify the square root of 98. So 98 is going to be 2 and what is that, 49? 49 is 7 times 7. So I have a pair of 7. So this does simplify to negative 9 plus or minus 7 with a 2 left over inside the square root. So this ends up being my two solutions. All right. How do we know it's two solutions? We get the plus and minus, right? We've got to make sure we use that symbol. All right, so I promised we'd go back to this slide, but we've already talked about this, so let me go ahead and move on. All right, so actually we're not going to move on. So I'm going to stop here, and I want you to focus on today completing the square. Now, remember, if I back up, this is the process we use when that a value is 1. So if you have nothing in front of your x squared, this is how you're going to complete the square. Okay, we'll deal with what to do when it's not a 1 tomorrow. But for right now, this is what you're going to do when it is a 1 value. Okay? All right, see you guys in class.